Folks, there are some new cool kids on the block, and they are called PyMC, Aeppl, and Aesara. And it's high time we give us a proper welcome. To do that, who better than one of the architects of the new PyMC 4.0, Ricardo Vieira. In this episode, he'll walk us through the inner workings of the newly released version of PyMC, telling us why the Aesara backend and the brand new RandomVariable operators constitute such strong foundations for your beloved PyMC models. He will also tell us about a self-contained PPL project called Aeppl, dedicated to converting model graphs to probability functions. Pretty cool, right? Oh, and in case you didn't guess yet, Ricardo is a PyMC developer and data scientist at PyMC Labs. He spent several years teaching himself statistics and computer science at the expense of his official degrees in psychology and neuroscience. So get ready for efficient random generator functions, better probability evaluation functions, and a fully fledged modern Bayesian workflow. This is Learning Bayesian Statistics, episode 65, recorded May 25, 2022. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the podcast, learnbayesstats.com is la place to be. Show notes, becoming a corporate sponsor, supporting LBS on Patreon, unlocking Bayesian merch, everything is in there. That's learnbayesstats.com. If with all that info, a Bayesian model is still resisting you, or if you find my voice especially smooth and want me to come and teach Bayesian stats in your company, then reach out at alex.andorra@pymc-labs.io or book a call with me at learnbayesstats.com. Thanks a lot, folks, and best Bayesian wishes to you all.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations.
What's a Bayesian? It's someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men, dropping placebo-controlled science like I'm Richard Feynman?
Ricardo Vieira, bem-vindo a Learning Bayesian Statistics.
Welcome.
Yeah, thank you. So how good is my Portuguese accent?
Oh, you were trying Portuguese?
Okay, I see that the podcast is starting very well.
It was perfect.
Thank you. Bem-vindo. I have to learn Portuguese. I want to go to Brazil, so I'll have to learn Portuguese at one point. And then we can remake that episode in Portuguese to open up the Portuguese and Brazilian markets to learn Bayes stats.
Perfect.
Awesome. And I'm pretty sure you're looking forward to translating all the docs from PyMC into Portuguese.
Of course.
The doc string, especially the code.
And the code.
Good luck with that, by the way. I don't know how I would do that in French. There are so many technical words that I don't even know in French that would feel so weird to me, like a foreign language, actually.
Actually, you can even translate. I've seen someone translate the Python syntax.
Yeah.
Instead of for loop and if. It becomes very funny when you think about it.
Yeah. Oh, yeah, in French, that would be boucle pour, boucle si. Oh my God. That sounds like a children's book. Boucle si. Oh my God. So actually, let's start with your origin story, because I have some structure to that podcast episode before you started derailing it. So as usual, I'd like to talk about how you came to the stats and data worlds and how sinuous of a path it was.
All right. So I come from a psychology background. So I did a bachelor's in psychology in Lisbon, Portugal, where I got familiar with all the frequentist stats. So my university, and I think the psychology in Portugal is like 20 years behind in terms of stats. So I got to learn all the frequentist stuff. But I actually did enjoy it. And then I went to do a master's in neuroscience. And safe to say that the traditional statistics are not good there or not sufficient. And that's when I got more familiar with not really Bayesian stats, but simulation-based still frequentist statistics, do permutation tests, shuffling, which for me, really clicked. I really like simulation-based programming. It really made all these traditional tests like t-tests, ANOVAs and stuff, when you do it in simulation-based, because you can usually kind of replicate the underlying test by doing a simulation, that really clicked and like really understood what's happening by literally writing it in for loops. And I think from simulation-based like statistics to Bayesian analysis, it's a very simple step, because you start with just simple, perhaps Metropolis Hastings and simple algorithms, which are all fancy for loops, but in the end, you're just doing some kind of taking random draws and doing interesting stuff with that. So I would say that that's how I came a bit into stats, Bayesian stats, and the computer stats by necessity. So
yeah, I understand. So for the record, fancy for loops in French, that's boucle pour fantaisiste, which is actually really cool. That's going to be the new name of the podcast. Welcome to Boucle pour fantaisiste. Okay, yeah, I completely understand. I mean, also for me, it was kind of the same. Like when I started understanding, like doing statistics with the computer and simulating samples from probability distribution instead of writing everything on pen and paper and doing painful computations where I always missed a minus sign or any other terms. Like I was like, oh, okay, statistics is interesting actually, because I can focus on like the things that we're good at and just give the things that we're bad at the computer. And the computer is really good at the things we're bad at. So that's cool.
And I think it gives you an understanding that just applying like a predefined test, I mean, you can try to read the derivation or assumptions and try to figure out where it comes from, but nothing like writing it or at least seeing the code written by someone to really understand what's going on.
Yeah, for sure. I mean, simulating at least an easier version is always something that helps your understanding a lot. I mean, even for PyMC code, before I do a PR, I kind of like don't really understand the thing I'm going to work on. And then when I do the PR, I'm like, okay, I see. I didn't understand anything. And then I think I understand. Then I have to write tests. And that's where I see that I didn't understand a lot even then.
Yeah, it's true. It's easy to get a false sense of understanding if something is working. And that's why we always add bugs in the PyMC library on purpose for pedagogical reasons.
Yeah, of course. Yeah. Because if there are no bugs, there are no PRs. If there are no PRs, there is no package. So that's why bugs are here.
And people use it, but they don't learn it because it would just work flawlessly.
Yeah, exactly. And that's what would life be without flaws, right? So you're welcome, PyMC users. And actually, so just quickly, can you tell us why you went into the neuroscience world in the first place?
So I had two options at that. Like when I finished my bachelor's, I could either go to clinical psychology, which would be interesting on its own. I could do more pure research, but where I was, there was nothing like cognitive science or like behavioral psychology. So the closest thing would be neuroscience with, in my case, animals, but you could also do it to humans. So I wanted to stay a bit more closer to pure research, and neuroscience was the options I had there.
I see. And your bachelor's was in?
Psychology, just like vanilla psychology.
Okay. Yeah, but it's interesting how like from psychology you went into stats, basically. Like it seems like psychology is very heavy in stats.
Yeah, especially cognitive psychology.
I see.
When people try to make theories that are more computational oriented, that really speaks to stats.
Yeah. So, I mean, I can refer, and I will refer listeners to, episode 61 with E.J. Wagenmakers, where, we talked a bit about that field, but not a lot, mainly about the methods and basically why non-Bayesian methods are still not used in a lot of fields, because we like to provoke a bit. And also to episode 31 with Michael Lee, where we did talk a lot about Bayesian cognitive modeling. So definitely, if you're interested in that, folks, I'll refer you to those episodes 61 and 31. Okay, and so nowadays, how do you define the work you're doing, Ricardo?
Nowadays, I have two roles, I would say. So I spend probably half the time contributing to the PyMC library and the ecosystem that lives around the library. The other half, I'm working with the folks at PyMC Labs just engaging in interesting consulting projects involving Bayesian models and using PyMC, but not only if needed.
I see. Yeah, I heard those guys are really, really good and cool at the same time. That's cool.
Rare combination.
Yeah, very rare indeed. And so mainly actually for labs, do you have some models that you mainly worked on, or have you worked on like a huge variety of models?
For labs, you meant?
Yeah.
So I have worked on the two more interesting ones would be the most interesting one. We are working on a crazy hierarchical model for research behavioral data, so with mice, which is quite in line with the kind of work I was doing in my master's, except we were studying fruit flies and we were not doing heavy Bayesian. And so this feels like the progress, 6-7 years later, doing a full hierarchical Bayesian model for behavioral markers in animals.
Yeah, that model is pretty amazing. And you worked on that with Luciano Past, right?
Exactly.
So Luciano...
Who is the mastermind?
Yeah, Luciano was on episode 63, I think. At the time of recording, the episode is not released, but by the magic of time travel, listeners will have heard about Luciano in episode 63. And actually, we didn't talk about that model. We talked about the model he worked on for HelloFresh and about mixture models. But we definitely should do something about that huge hierarchical model for mice, because that's really, really very interesting, and will give birth actually to a paper with Luciano's name on it. So definitely that's something worth covering. Okay, and so actually, do you remember how you first got introduced to Bayesian methods and why they stuck with you?
Well, I don't remember exactly the time. I remember a book that was quite influential from Alan Downey.
Yeah.
I think Think Bayes or something like that, which really grabbed this approach that I really enjoy of just coding from the bottom up all your models and analysis, and just spoke to me and then introduced kind of with a Bayesian framework. I have no idea if that was actually my first exposure. It was very gradual and accidental. I think by the time that I really had a good picture of what the Bayesian analysis and the way of thinking was, I was already deep down in it, like a fish that figure out that is in the water.
Yeah. And so how was that? Were you already doing your PhD?
So it must have been before my PhD. My PhD was, then I moved after my master's to Budapest in Hungary, and I started a PhD in cognitive science, working with a group that's very focused on Bayesian models of cognition. So by that time, I was already familiar with Bayesian stats, learned a lot during those years, but that came after, I guess, must have.
But were you using those in your PhD, or like was it?
That's when I started using PyMC, actually, yeah, for instance.
Ah, okay. So like during your PhD, you started using that, and then you just dug more and more into basically the method instead of focusing on the neuroscience side of things.
Yeah, exactly. And then at a point, started working on the tool instead of the subject.
Yeah, basically the same as for me. But why were Bayesian stats interesting for your PhD at the time?
Well, there are very interesting theories about human and animal perception, or just what the brain is doing, which boils down to, could it be that everything that's happening is just Bayesian inference at like different levels of granularity? And that's kind of the topic that I engage with in my PhD, more at the level of memory and decision making. But you can find, if you are interested in neuroscience and human behavior, you can find a hypothesis that all kinds of behaviors may, in one way or another, represent some form of Bayesian computation, or at least an approximation of Bayesian computation.
So that's actually interesting, because basically the lyrics of Good Bayesian, the podcast's theme song, are about that, like how the brain works from a Bayesian perspective. I think the very first lyrics are about that, yeah, if I remember. I'm trying to already remember the lyrics. Okay, that will come back. Maybe by the end of the episode, I'll be able to sing it. So let's start talking about PyMC. Before that, how did you start contributing to PyMC?
So I actually gave a talk recently on my first contributions, and I went and checked what happened.
Ah, right.
Because the funny thing about open source,
We need the link, by the way, to that talk in the show notes.
Yeah, I will put it. The funny thing about open source contribution is that everything is there forever.
Yeah.
So I could dig my archaeological past.
Yeah.
And it started with a very naive just suggestion to add some different parameterization to the negative binomial distribution, I think. I mean, I asked guys, can you just add this? It could be useful because I'm reading other papers or other demonstrations, and they always parameterize the negative binomial with these two parameters. Then I got a surprise response of, yeah, sure. Would you like to be the one doing that?
And that response would be from Thomas Vicky, I'm guessing.
Thomas, yeah.
This is the classic Thomas sneaky answer. Sure. Oh, yeah, that'd be awesome. Would you do that?
Exactly. And actually, you showed up in that first PR I did. I was asking help for how to write the test, and you gave a suggestion there.
Oh, I didn't just insult you? Oh, that's cool.
No.
Because normally that's my normal answer.
Well, you just said, it's already written, just copy and change the parameters. It was not insulting at all.
Yeah, nice. That time I had way more time to contribute to PyMC than I do now. It's not good. But I'm actually, next week, so that's completely useless to the podcast listeners. But the time we're recording, next week, we're going to do a huge PyMC-wide hackathon that I think is going to be public, actually, to try and push PyMC 4 release as fast as possible. And it's going to be very, very much fun. Really looking forward to that.
As fast and good as possible.
But it's already as good as possible. Oh, yeah, very, very important question. Do you say PyMC on or PyMCon? Or PyMCCon?
I never said it out loud, I just saw the letters. I'm a visual guy. I say that I will defer that to when I participate in the next one.
Okay, perfect. So you say PyMC on. That's on the record. Because PyMCCon doesn't, no. When you have the opportunity for a portmanteau or a pun, you seize it, right? Otherwise, life is boring. So PyMC on it is.
I feel I'm trapped in some kind of vendetta of yours.
Yeah, especially a completely outdated vendetta because it was last year's debate. So the guy doesn't leave, the bone alone. Okay, so let's talk about the new PyMC 4.0 action, because you said that you work a lot on that and I can vouch for it. That's true. So can you give us a high-level overview of 4.0 before we dive in?
It's the same, but better.
Okay, perfect. So next question. What are the main changes, the main novelties, and what changes for users, and does it break things from V3?
So from the outside, what users write should be mostly the same. So it should look the same, but it's going to behave very differently under the hood. And mostly it's going to behave differently when doing forward sampling.
Yeah, so prior predictive and posterior predictive.
Prior predictive, posterior predictive. That's completely revamped.
Which is awesome, because it's going to work way better.
Yeah, and much more well integrated with also the log-P side. The biggest difference is you're going to be able to do forward sampling much faster and more often than what you could do in PyMC 3 without having to do anything new.
Yeah, without the shape issues, basically.
Without shape issues as well. So actually, it's interesting. So if for those who are familiar with Stan, which I guess will be most of the listeners to the podcast, Stan takes an approach where you define a model based on densities. So you specify your model by basically saying, what are the densities of the model? And in PyMC 3, that was kind of also how you did. But in PyMC 4, we changed gears completely. And actually, what you create when you write a PyMC model is the forward sampling model. So you define your model in terms of these things called random variables, which you can think just as you define them in terms of the random number generators, which I think is very, very interesting. And it's going to be a different approach going forward. And that might lead to different ways of thinking about Bayesian modeling.
So basically random generators. Okay. Instead of, and the density here would be what? Like if you can give the distinction.
So instead of defining your model as, for every, so when you say I have my prior of my parameter follows a beta distribution, instead you are saying add beta density for the value of the beta in this potential that of the model. In PyMC, you say there's going to be something that takes beta random draws, and downstream of that, there's maybe going to be a normal that takes these beta random draws as the mean, and some other variable as the sigma and takes normal random draws. So a bit like if you're writing taking random draws in NumPy, you would just concatenate a bunch of functions, that take random draws that follow specific distributions, and this would be the way to generate maybe simulated data. But interesting in PyMC, that's exactly what you do when you write PyMC model. You just have a symbolic version of this graph because we use symbolic computation in the backend. But until this point, there's no log P's or densities or anything in the model you define.
So everything is based on the random variables, basically now.
Yes.
They are the core foundation.
Exactly.
In that way, basically they are symbolic objects, and then they become a density when you need to evaluate the model, for instance, or they become a random number generator when you need to forward sample.
They are already a random number generator. We literally do this inverse process that's so many times mentioned in the textbooks, right? We have a kind of a generative model, and then we invert it, condition on the data or on the latent parameters. And that's when we go and replace the random variables by the correct respective densities, or PMFs if it's discrete variables.
Right. So this is done basically on demand. Like these are objects, basically, and then they become something concrete, like a density when you need to sample, either backward sample or forward sample.
Backward, I don't know if you call it backward sampling, but you're not sampling,
Yeah, I call that backward sample. I don't know why.
Backward sampling.
There is forward sample, so it should be backward sample because you're going from data to parameters, right?
Yeah.
So it's backwards.
Yeah, I'm not the biggest fan of the forward sampling. I prefer to think of it as ancestral sampling because it really follows this. You take draws from the ancestors and then you kind of cascade downstream.
Yeah, that works too. Then what would be the other way around?
The other is completely different. It's just you put some MCMC there and just propose values until it kind of looks like it could have been generated in the first place by ancestral sampling.
Sure. So it could be ancestral sampling and what? MCMC sampling?
Fake, look-alike ancestral sampling.
Okay, yeah, pun taken. That could be interesting. So basically, from what I understand, this is very interesting to have those random variables as the core of the symbolic graph that are the model.
And also, I think it's interesting in terms of probabilistic programming language, because I think many users or people who think about Bayesian models have a tendency to think in this way. They don't really think in terms of, some people will do, of course, but most will not think in terms of densities and PMFs. They think in terms of more closer to the random draws. If I was kind of simulating this with some uncertainty, what would I expect? And that's also a big part of what we emphasize in the Bayesian workflow, right? Just do all these posterior predictive checks or the prior predictive check, just to have a feeling of what it would look like. And if it looks reasonable, then you can do some posterior inference, or you should only then. And so it makes sense that the thing you create, the model you specify, is actually in terms of the random sampling.
Yeah, I really love that. So that's from the user perspective. From the developer's perspective, which power or which powers do RVs, so random variables, unlock? And maybe that's when you can talk about rewrites. That's very, very hard to say for a French guy. Appreciate my effort, because most French people would say rewrites. So is that related to rewrites, or is it completely unrelated?
It is, in a sense that calling something a normal random variable and encapsulating in that object is something interesting when you want to do graphic manipulation. That would be slightly more difficult if you instead just added the expression of the log P of a normal. Because if you want to do interesting probabilistic graph manipulation, it's perhaps easier to think in terms of random variables than densities or PMFs. Just because you can say, okay, I have another normal, I'm adding the two together, so I know this is going to be another normal, like a convolution of two normal distributions, and I know that I can just add the means and the standard deviations to get what the output is going to be like. And with densities, this would be more difficult. You would have to do more pattern matching to know, okay, this is the density of a normal, this is the density of another normal, and they would look like this together. And this brings graph rewrites, which PyMC is all addicted to, or at least the idea of, that if we have a concise way of expressing our generative graphs, in this case, we decided to try with random variables. This opens the room to now do all sorts of graph manipulations if the users want, after one model is specified. Stuff like, let's just switch between centered and non-centered parameterization. it should be very easy because we can do some simple pattern matching and just output a different model that represents the different varied parameterizations. And that's definitely something that would be very difficult in V3 because we didn't build graphs in terms of random variables. We had this something very abstract that you could take log p's of, but they were not proper objects. And now in V4, that's very clear. They are there and we can tell them to do whatever we want with them.
Yeah, that's super cool. So basically having these objects as the core and unlocks amazing powers like rewriting the model on the fly and, for instance, doing reparameterization automatically.
Or finding, for instance, conjugate priors if you wanted. It's easier to do outside of all kinds of clever pattern matching, just because you have some nice structure to work with.
And is that already implemented?
Some things are, but mostly there's interesting experimental libraries thinking about these ideas that are popping up from the Aesara, the backend folks. Some things will pop up in the future. Already exists the PyMC experimental library.
Yeah.
So basically with V4, we introduced the building blocks, and now there is the possibility of starting to explore. And I think in 1 year time, it will be interesting to see what actually emerged and eventually was joined to the core PyMC library.
Yeah, because the idea is that we experiment, and then if it's good enough, we add it to the core PyMC library.
Definitely.
So actually, I wanted to talk about that. So let's talk about it right now. So is that what Aeppl does? So not the fruit, not the computer company, but the Python library. Is that what Aeppl is for?
Aeppl is related to that. So the goal of Aeppl is do what PyMC already did before, which is, okay, so the goal of Aeppl is if you give it a graph defined in terms of random variables, hopefully any arbitrary graph that can be measured, and can think about what this means later, it will be able to tell you, okay, this would be the log probability of this graph if you condition on these variables having certain values, which for the simplest cases, which most users, when they are writing a PyMC model, they just say X is a normal, Y is a normal centered around X. Something very trivial because we just have to replace each of these normals by the density and then put the values that we are conditioning on. But this is the simplest case of what we can do. And Aeppl does this, and we do use it for PyMC, but it also does much more. So if you have some deterministic manipulations of random variables, for instance, if you exponentiate a beta distribution, you can take the log p of this, right? So users can just say X follows a beta random variable, Y is the exponent of X, and I want to know the log p if I condition on Y, which under the hood would be the equivalent to an exponential beta distribution, which I never found in my life. But from the Aeppl standpoint, this is just almost like a pure random variable for it. So it can tell you what would be the log probability. So the idea is that you can use your normal distributions as building blocks, and you can compose them almost arbitrarily to just create new structures and do inference on those as if they were like pure distribution or pure random variables. One example we have in PyMC already, which we used as a demonstration, is the sensor distributions, which we added recently. And the sensor distributions are very interesting from a generative, so from a forward sampling standpoint, they are very trivial to do. You take a draw from whatever is your base distribution, like a normal base distribution, then you just clip it between a lower bound and an upper bound, like a deterministic operation. So let's say you have a sensor normal between -1 and 1, and every time the normal gives you a 2, for instance, you just say, okay, this is actually a 1. So you clip the values, and this gives you random draws from a sensor normal distribution. And what Aeppl does in this case is we show it this graph, which is just a clip of a base distribution, and Aeppl can tell you, okay, this follows the density of a sensor normal distribution. So we put some log CDFs there depending on the values, and we can get the proper log p expression for this. For the user standpoint, is very nice because he never had to worry about CDFs or branching expressions for the density. He just had to say, I have a normal, I clip it. What should be the log p?
Okay. So basically in theory, users won't have to interact with Aeppl, which is written Aeppl, by the way. So they wouldn't have to interact with Aeppl because Aeppl would just interact with PyMC, like Aesara interact with PyMC, and Aeppl would do that magic behind the hood without users even knowing it.
And from a user, so users who are not very familiar with this, the closest analogy is that in the future it will be possible to condition on deterministics kind of. So users are familiar with doing deterministic operations. If you have a latent variable and then you just do something with it, like exponentiate it or add 5 or whatever, and then you wrap it in this PyMC deterministic just so you can have it in the trace. But what if this was actually your likelihood and you want to say what I observed was actually the product of this deterministic operation? So that's what Aeppl will be able to do in the future. So you could actually, we'd probably do something else, but you could have something like, PM deterministic expression observed equals my data set.
And why is that impossible for now?
It's just we didn't put it there yet, but we have all the building blocks with random variables and Aeppl to do it. But right now you cannot pass observed to deterministic, right?
Yeah. And so these are basically what you call rewrites, right?
These are rewrites to get you arbitrary log P's, log probabilities for a generative graph.
Yeah. And basically the log P is what you need in the Bayesian framework, because then that allows you to do MCMC sampling and stuff like that. That's why it's so important, right? You need the log P of the whole model.
Precisely. And specify what are the variables you are conditioning on.
Yeah. So these are the rewrites. And does automatic reparametrization fall into that rewrite bucket, or is it something a bit different?
That's also a rewrite, but you can think that that's a rewrite that can happen before you ask for the log probability. So and that's why defining a graph in terms of random variables is so useful, is that you can have a graph that explains how your hierarchical model generates draws. And now if you want to, you can just pass it to a function that just does the rewrite, for instance, to take away the center parameterization. So it would just put the raw normals multiplied by the scale and add the mu. And then you can pass this to Aeppl or whatever to just get the log prob. So you just do manipulations at different levels of representation. And usually you do most of the interesting ones before you ask for the log probability. Because again, it's easier to think about normals when they are an object than instead when they are a density, which is just a more convoluted mathematical expression.
Yeah, so it's basically really, really like almost the same, I think. So that would be taken care of by Aeppl 2 under the hood.
These rewrites will be taken by PyMC and other libraries. Aeppl will try to keep the focus of only worrying about once you have the final graph that you want the density for, it gives you or that you want the log probability for, it gives you that mathematical expression. So it adds the annoying densities and everything.
Yeah, it doesn't change the graph. The graph is changed before. So like automatic reparameterization, so for instance, from centered to non-centered would be done by PyMC itself.
Mm-hmm.
I see. Do we already have that? Or is it something we're still working on?
No, we will whenever someone wants to play with it. But we have the building blocks there for it. And that's what's really exciting.
Yeah. And so the idea, so at listeners understand, is that you have a hierarchical model that you define in a centered way, because it's usually way easier to define your model in a centered parameterization way. But often hierarchical models work better with non-centered parameterizations, which can be very weird to code, because like you have to rescale the standard normal and add the mu, and that just makes the code more convoluted, and that's more complicated to understand for people who look at your model, basically. And so here the idea would be like you could have a keyword argument, I guess, in the pm.model function, which says automatic reparameterization equals true. And then if needed, PyMC would reparameterize to the non-centered under the hood, but you wouldn't have to change the code.
Yeah, and it can be arbitrarily smart or dumb as it wants. For instance, it could decide to do it to do the non-centered parameterization only if you have, less than X siblings, because there's some interesting analysis that show that sometimes the centered parameterization might be better, but you just need a lot of descendants from it, and we can do that kind of stuff. Yeah, the idea is the user, hopefully it will be faster to just try different parameterizations of the model, and you won't have to write it yourself, which sometimes can be cumbersome or even introduce bugs, although the non-centered is quite trivial. There are other parameterizations that can be quite involved.
Yeah, because here the idea is not to only do that on the non-centered parameterization. It would be to be able to use other reparameterizations, right? Like what?
So one interesting is depending on whether you are conditioning. So if you have a complex likelihood or unobserved equivalent variable, sometimes you would write it differently. So for instance, you might have, let's say, a Gaussian random walk that then you transform to bound in some way. Let's say that you are using a Gaussian random walk to give you, I don't know, a probability of a binary probability that goes into a Bernoulli. And you might sometimes, let's go with that example. Sometimes you might write the model differently depending on whether you are conditioning. I have a better example. Okay, a better example is the sensor distribution, actually. Okay, so the sensor distribution, which we introduced, it's very interesting in that you cannot really do nudge sampling with it if it's not observed, because it adds this hard switch, which are not differentiable. So you cannot use usually a censored likelihood to do MCMC sampling. So usually what you do is, if you did not observe the sensor distribution, you just do it in the generative way. You say, I have a variable that follows the originally non-censored distribution, like a normal. And then you do a deterministic clip. And then you input this to something else if you are doing a non-observed, like latent censoring process. But if you are observing, then you actually have to pass the likelihood directly. Of this censored variable. So basically you write two different models for the same kind of process, depending on whether it's observed or non-observed. So if you just use as a latent parameter for something else. And with automatic rewrites, we can do this behind the scenes. We can check, the user said they want to have a censored normal. If they are observing it, we can just give the likelihood directly, because there's not going to be any nudge sampling of this variable. It's going to be static. But if it's not observed, then we can keep the original process where we sample the latent non-censored variable, and then we just censor it deterministically afterwards. And the user wouldn't need to specify different models depending on what they are doing. So this is another example. So it takes away this distinction between writing equivalent models that are going to be sampled, where the variables are either going to be sampled by, let's say, nuts, or they're going to be conditioned on.
Yeah, so basically having these random variable graph, just like this is if you want, the idea of the model, but then the way the model is sampled isn't that relevant to the user. So the idea would be to do that as automatically as possible under the hood, because it's just much more from a sampler perspective that you need to do this reparametrization. These reparametrizations are not that relevant to the users, so the goal is to automate that away. And a good way to do that is to have that symbolic graph of random variables that we talked about.
Exactly. Great summary.
And so do we have an issue somewhere or a discourse post that people interested, like if there are listeners interested in working on that, because you said we have all the building blocks, now we need to just put them together to enable that super cool new feature. If there are listeners interested in that, where should they go?
I would say just jump on Discourse and open a topic and mention me or any other core dev, and we will guide you.
Yeah.
There's no open issue yet explaining the ideas.
Okay.
They are emerging a bit gradually. But if people are interested in this, it's definitely something we would welcome contributions for. I guess on Discord is a good point. Not on Discord, sorry, on Discourse.
Discourse, yeah. Okay, for sure, if you're looking for contribution that would be very, very valuable to the PyMC package, this is definitely one. So this is an official LBS call to action. So if you are listening to the podcast while doing your dishes or driving or walking your dog, stop right now and listen to that.
Bring the dog home.
Yeah. Go on Twitter or on Discourse and you tag Ricardo Vieira, or you tag me on Twitter or Discourse, Alex_Andorra, or Learn Base Stats, which is the Twitter handle of the podcast. And you tell it, you ask us about what can I do about that reparametrization PR, and we'll introduce you to the right people, because we know people. Okay. So definitely get in touch if you're interested in working on that. That would be awesome. This is the end of that official LBS call to action. We should probably have a background music behind that announcement. Add that in during editing, like a CNN breaking news, music. Okay, so timing is flying by, and I want to talk about users' favorite feature of PyMC version 3, which were, of course, shape issues. So please tell me that you kept them around.
No, we had to make the hard decision. We dropped the shape issues.
What did you guys do? So what do you mean by that?
So it's safe to say that PyMC3 grew very gradually, organically. And one thing that kind of was not planned in advance was the dimensionality of our variables. And I think that it was a recurring joke that every week someone would find a way where the dimensionality was broken, or would things with the same shape would end up with different shapes because they would grow, let's say, in terms of dimensions, they would grow to the left where the others would grow to the right. And especially when you had multivariate distributions, things were a bit fuzzy. But with V4 and with the introduction of the random variables, we created a very stable APPI about how the shapes of random variables should be handled. And we always start by just thinking about the pure case. In the most simple case, you have let's say a normal distribution. It takes one value for the mean, one value for the sigma. It gives you one value if you do a random draw. And then you, because of vectorization and a lot of these great ideas that were brought from NumPy and other array libraries, obviously it makes sense to think not just in normal, in terms of the core distributions, but batches of them. So people might say, okay, instead of a normal distribution, I want a vector of 3 values, each of one follows a normal distribution. And for that, you can give 3 means, or you can give 3 sigmas, or you can give 3 means and 3 sigmas, or you can give 1 mean, 1 sigma, and just say, give me something with a shape of 3. And these different combinations, they work pretty straightforward in the case of simple distributions, which are univariate in the core case. But in many other more complex cases, and mostly multivariate distributions, they led to some inconsistencies or some kind of unwritten rules about how they behaved. And that's something we had to sort out, and we did for V4. So everything, you should be able to know how an arbitrarily complex multivariate distribution is going to behave without having to put values and seeing if it fails or if it gives you the draws with the right shapes.
Which is cool.
Yeah,
can't wait for that. Yeah, actually, that's awesome. And I mean, it's one thing, like we kind of all knew that we should do it and how to solve it, basically, but it's just like it required rewriting a lot of core PyMC code, and basically that required having another major version, which is exactly what we ended up doing in the end, right? So finally it's there. I think we also have to talk about the foundations of PyMC, and I mean, every house needs its foundations, right? Although I have to caveat that because my whole knowledge about house building comes from the 3 Little Pigs. So maybe I'm completely wrong about that. But I heard in that thing that every house needs its foundations. And PyMCs are coming from its new backend. Can you tell us more about it?
Sure. So Aesara is our fork of the famous Theano library that was discontinued some years ago, which really brought symbolic computation and fast symbolic computation to the Python world. It was very used in the deep learning ecosystem. Had all the fun stuff, autodiff, arbitrarily high dimensional tensors, following heavily inspired by the NumPy API. And that's what PyMC3 used as the backend, mostly to get auto-differentiation for nut sampling. And that was pretty much what they did. And then in V4, we are actually making use of other abilities that Theano already had, which I'll mention are even better now in their offspring Aesara, but now with these random variables and the ability to manipulate the generative graph, we are making use of a lot of functionality that Theano always supported and was always a bit unique in that. So many other tensor libraries have emerged since Theano was released. Most famous nowadays is JAX perhaps, but also PyTorch, TensorFlow. And they all have this autodiff and tensor API that Theano also has. But interestingly enough, they do not have or do not support as well the ability to manipulate the symbolic graphs before they are evaluated. And that's something that Theano did well, and that with Aesara that we fork now, we are supporting even more and making it more accessible at in a Pythonic kind of way. And it really makes writing a probabilistic programming language, which PyMC kind of does, much more interesting because it gives you tools to manipulate graphs according to whatever constraints you want before you compute them. And then once you compute them, it also allows you to compile it to C backend and Numb and JAX. So it allows you to compile your code, your graph to code that's very fast and nice to run on your computer. But before that, it also allows you to manipulate it in according to your mathematical desires.
Yeah, I mean, clearly Aesara is one of the workhorses of PyMC and is incredibly important. For the users, though, how exposed are they to it when they use PyMC? Do they also need to use Aesara, basically, or is it more for advanced use cases?
They are always using it. Whether they know they are using it or not is a different question.
Yeah, I mean explicitly.
Right. So every time you do some operation on variables that is not included in our helpful pm.math, you usually import. You used to import in PyMC3, you used to import Tiano tensor to do these operations, and now you import Aesara tensor. But the idea is you shouldn't have to think much about it if you know how to write NumPy expressions, because we follow the NumPy API as a guideline. So if you are used to doing a NumPy where condition if else, you do the same with the Aesara tensor dot where, and you pass a condition if else, for example. So users in Python shouldn't have to. Obviously, every time you dive a bit deeper or you have to find a bug, you're gonna one way or another you're gonna find that you are getting exceptions from Aesara. So that will always crop up. But ideally, when things are working nicely, you just have to think about how you would write your generative graph, maybe in NumPy, and replace some of those calls by PyMC distributions and others by Aesara tensor operations.
Nice. Super cool. So if we de-zoom a bit, because we've talked a lot about that, about the package and like special features that we have now. If we de-zoom a bit, because you've been working on that for basically a year, right? I'm wondering, what are the main difficulties you encountered with a new version, the whole project, and what you learned from all of that?
So I think that, when you want to renovate your house, to keep your metaphor, you have to go back, see how the foundations are doing, and you have to try to perhaps maintain them or improve them without destroying what you had there. And in this, when we're talking about PyMC and we're talking about Aesara, we are talking about code bases that are, I think safe to say, more than a decade old, right? And they grew kind of organically over time. So a lot of it is a bit of archaeological work, just to figure out if something is not working or it's odd, why is it there? Can we move it aside? Can we take it? Do we need to keep it? So it's a lot of kind of investigate why things are there before you try to break them. And I think that's pretty characteristic of any mature code base, right? That just has grown over the time. And the people who wrote it are not there to tell you why they put it. Sometimes the comments are not very useful. Although both Tian and PyMC had a good, a healthy kind of maintenance over the time. But it's mostly learning and figuring out why things are there.
Yeah. And first, definitely from your continuing my metaphor, I can tell that you too have read The Three Little Pigs. So well done on that. I see that you have been following my recommended reading list. So that's perfect. And second, this detective work is definitely one of the most, what takes the most time. Each time you do a PR, when things don't work, it comes from some part of the code base that you didn't think you would have to deal with. And you're like, what is this stuff doing? What if I remove it? Oh no, my computer burned. But yeah, I understand. And it's also from a recruiting point of view, how complicated was it to get new folks joining and contributing to that effort to get the new major version?
So it's fun. We had both of two kind of contributions. We had, let's say, decoration contributions where didn't involve working with any of the foundations. Stuff just we just need to change code a bit so that it works now with V4. And those were fun because we could just go on Twitter and say, hey, here are 100 issues we need to sort out. Anyone wants to join? And we kind of get a wave of people excited about it and opening PRs left and right. And then we have these issues that require I would say, a bit of a bit of stupidity to accept, to engage with, which require you to be a bit brave and dive deep. And I think 99.9% of the time, not knowing any of these layers you are diving through, just to get to the issue, and be willing to risk doing something, or risk failing, or risk breaking everything, which are very welcome. And surprisingly, I understand. I mean, it's difficult because once you accept this, it's probably going to require you more time than what you have. And it's the chance that you'll end up not succeeding is also relatively high. But the chance that this work is useless, it's very low, actually, because it makes clear for everyone who is active at the time what are the issues, what are the boundaries. So even if you are not the one that in the end writes the code that gets merged to fix whatever issue it was, you contributed in the process that led to that code being written by someone else.
Yeah, I see. And getting people involved in the open source development is something I find interesting, and something I'm trying to do also with the podcast. So hopefully you listeners will go to the GitHub links and so on, or just ping us on Twitter, or at least me. I don't want to flood Ricardo with requests. I'll send them to you after some filtering if you want.
It's perfect.
Okay, so before we close up the show, I'd like to ask you a more general question about the Bayesian workflow, and that would be, what do you think are the biggest hurdles in the Bayesian workflow currently?
That's a tough question. I think that a bit because of Bayesian workflow is characteristically flexible in that your imagination is your limitation.
That's beautiful.
Yeah, I think it's interesting that this is also can be a bit paralyzing because you can just try infinite combinations of different models, different parameterizations, and it becomes one. It's always possible to find a model that's going to sample a bit better, or that's going to give more reasonable inferences. And I think that knowing when to stop, or having a more guided approach to trying different models is a very challenging thing that's brought in part by the flexibility of the modern Bayesian workflow. So I would guess not necessarily automatic tools, but any guiding principles of how to do this, iterate in this process, I think it's going to be very useful in the next couple of years, just because we can do so many permutations and different combinations during the exploration of the modeling process.
So you're trying to do that from a more automated way?
I think automated way definitely going to play a role. It already does a bit if you look at, let's say, like deep learning competitions, you have people trying automatically different, just because the parameter space is so large. But also in the Bayesian setting, we also always have, or can have, the more top-down constraining of what you expect data to behave like. And I think that probably you're still going to combine the two in the time future. So you might have deciding for all your hierarchical variables whether the sampler is going to behave nicer in a centered or non-centered parameterization. That's something that probably can be automated. But thinking about what the building blocks are, or what the constraints that are going to be consistent across different manipulations, they're probably going to come from a top-down approach.
Nice. That would be cool. I would definitely be down for that. So personally, do you have any project that you're excited to work on for the coming month?
Yes, too many. Too many. Okay, so some of the things I mentioned, all the things I mentioned, and I said they are not there yet, but we have the building blocks. You can probably guess I have some ideas that I would like to, whenever the more pressing issues get sorted out.
Yeah.
But yes, I have many.
So give me the main one.
The main one is, it's this kind of allowing to define these arbitrary PyMC distributions, because we know that APPL is clever now and can do a lot, so that users, if you want, let's say a log normal distribution and it doesn't exist, you just get a normal, say, I exponentiate this and I want this to be my variable in the model. So this is something we can already do, and we want to make it nice for PyMC users to be able to use this functionality. Mostly because, to be honest, I hate the name log normal.
Yeah, me too.
Because it is a normal that was exponentiated.
Yeah.
So I want users to be able to say, my distribution is an exponential normal, and do it the proper way. But in general, we were really excited to open up these new functionalities to the user and then just see what crazy stuff they will make.
So would that mean it would be like I could do pm.math.exp of pm.normal mu equals 10, sigma equals 100. because always take a huge sigma for your priors, folks. It's very important. It's the best prime.
And say that this is the variable that I'm sampling. That's the thing I'm going to give a name, and that the nuts is going to be conditioning on, or that I observed my data follows an exponentiated normal.
But basically, you could do like math operations on the distributions instead of on the parameters of the distributions.
Exactly. And say that this is my distribution.
Oh, yeah. So that's a new distribution, basically.
Exactly. Obviously, the normal, we have it because it's so useful, but you can do for anything.
Oh, we do?
Yes. So you can have an exponentiated, exponentiated. I'm sure there is a double exponentiated distribution somewhere.
Yeah.
The idea is, again, give even more building blocks wherever we can, so that we don't have to work in the future and implement these things when users ask them, because you can say, you already have it. Just call expon it. And I think that, yes, we don't want the PyMC, let's say, what's already written in PyMC to be the limiting factor when you are doing a Bayesian workflow.
Yeah.
So that if you could write it in paper, hopefully you can write it in PyMC and it will behave as you expected.
Awesome. Oh, yeah. One other thing where we need to add is zero-sum normal.
Zero-sum normal.
I know it's ready for V4, but we need to do the PR, folks. So, if you want to hold me accountable, ping me on Twitter and ask me. So when is the zero-sum normal going to be available, Alex? I need to work on that. I know.
For those that don't know, Alex is being tricky here because I think for the last 2 years, I've been seeing Alex write messages on our internal chats of, guys, I'm going to do the zero-sum normal. Anyone wants to join along? For, 2 years, it's perhaps safe to say. But now I've seen this change strategy and they said, when are you going to do it? I don't know if this is a different cycle of acceptance.
Yeah, probably. Damn. This never is kind of a priority. But I need to make it a priority. That's my point.
Exactly.
I'll get to it. Usually that's how it works.
And this is the 50th time he mentions it.
Sure, but
it will come.
When I say something, I usually do it. I didn't say how long it would take. Maybe 10 years.
Have you done an episode on zero-sum parameterizations?
No, but I have something in mind. Maybe not an episode, but a YouTube video for the Labs channel, which would be a good incentive to do the PR before. You see how I'm trying to trick my brain into doing that because I understood how part of my brain works. Okay, so before letting you go, actually, talking about stuff that drag on, I know that a lot of people ask you, so when is PyMC V4 going to be out and things like that. So, and we're probably tired of answering that question. So I wanted to ask you a different question, which is, when do you think PyMC V5 is going to be out?
6 months after V4.
Okay, that's on tape. Perfect. You've heard it here before, folks, right? LBS first, number 1 on Bayesian news. Okay, so now the last 2 questions I ask every guest at the end of the show. First one, if you had unlimited time and resources, which problem would you try to solve? And you cannot answer zero-sum normal PR.
Yeah, I was thinking about this question because you told me you would ask me in advance. And I was thinking there are, just a low level. So in my programming work, there are these small issues that I don't do because they are not urgent. And there are these big issues that I don't do because I don't have enough time. And I wonder if with unlimited time, I would be doing more of one or the other. Would I be wasting more time or feeling that I have more time to take on risky ventures? So I know that I would cycle between urgent and the bigger kind of problems to solve with a different period than I do with my limited lifetime. But I honestly don't know if I would be cycling back and forth faster or slower. I just know it would be a different exploratory phase. This because by nature, I like to switch and work, different kind of problems over time. And my interests come and back, usually without me planning in advance what I'm going to be interested. So I know that with unlimited time, I would probably keep this process. I'm just curious whether I would stay longer or shorter periods before I jump.
Yeah, I understand. I think I'm kind of the same. That's not a reason to not answer the question, though.
Right.
I saw what you did there. You tried to be a philosopher and so on and drown the question.
No, I was thinking this is my background, optimizing action decision in the case of uncertainty. And you are telling me, okay, now you have no time uncertainty anymore.
Yeah.
Right. Naively, I would think I would try to do more try to answer more difficult problems, whether statistical problems or infrastructural problems or even social problems. Sometimes I feel guilty that I don't work in climate science or I don't work in cancer research. Probably I would still not do it. I would feel just more guilty about those. And I would spend more time doing the things that naturally attract me, which nowadays involves a lot of Bayesian computation and stats.
Well, that's good to know. Means you already love what you're doing. So that's cool. Second question. If you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
If he's a good cook and he's cooking, then maybe that's more important. No, I was thinking about this, and if you indulge me and say that historians can have a scientific mind, I'd probably say historians, just because I love listening to crazy historical periods or events that happened. And I think they make for a great dinner conversation. So perhaps some historian or perhaps some famous podcaster in history, because I've already used to listening to those. But so then I was thinking that perhaps the more interesting scientific conversations are the ones that are done after a problem is solved and you have a nice, neat picture of the history of the discovery. So perhaps some science communicator would be I would choose a famous intellectual science communicator would be who I would choose to have dinner with, because those are just the kind of stories I love to read, listen about. And to be honest, I've met many scientists and they are still in the murky phases of finding out what they are investigating. And those will not yet be the interesting dinner time stories. So I love their work. I just wait for them to be well curated.
I see. So bonus question. In which period of history would you go back if you could visit for, I don't know, let's say 1 month?
Do I visit as a spectator or do I have to live in the environment? Because that changes the question. I don't want some of those diseases.
Yeah, I know. So let's say spectator, because otherwise, if you have to leave, everybody will say, well, right now, because you have no interest in going back in history.
I actually am very curious about the very ancient times, the first towns that were built. Just would love to see what were humans then like. I have this big fascination about the history of cities. Usually I like to think of history in terms of using the city level representation. And one of the most interesting for me is the city of Venice, which has a crazy long history from people hiding in the swamps from the invading hordes that were invading Italy, to becoming a superpower, to becoming a decadent superpower, to becoming a touristic museum. And I would just love to see those beginnings, what it was like.
Yeah, definitely. I mean, Venice is crazy. Just the idea of let's build a city on water
on mud that gets flooded.
I think the 13th or 14th century. It's crazy. That's awesome. Yeah. Yeah, and I love your point about science communicators and so on. I think, so I've recently read an awesome book about physics, because I'm diving kind of deep into physics these days. And it's called We Have No Idea by Jorge Sham and Daniel Whiteson. It's really, really great book. I loved it. And I think they're really good science communicators about physics and about the fact that we don't know a lot, we really don't know a lot about the universe, but we do know a bit. And so they managed to get in the middle of that, and that's awesome. So I would definitely love to have dinner with those guys. And they are pretty funny. The book has really fun parts. So definitely love to.
Okay, don't forget to invite me then when that happens.
Yeah, for sure. I will. Awesome. Well, Ricardo, muito obrigado.
Wow.
I'm going there. Right. Muito obrigado. Obrigado. You'd say it like that. Ricardo, that was awesome. I learned a lot about V4, surprisingly. So many things happening at the same time. It's super hard for me to keep up with everything. So that was actually great to have you on the show, to have a clearer mind about the whole state of the package and where we're heading, where we are headed. I hope listeners learned a lot too, and they're excited about that new PyMC version 4 getting out the door very, very soon. Hopefully when you listen to this episode, folks, V4 is out. Hopefully. And yeah, as usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Ricardo, for taking the time and being on this show.
Thank you.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or on Podchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, with MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.